Let's begin by recalling the three trigonometric ratios, sine, cosine, and tangent. Remember we use SO, CA, TOA to help us do this. SO, S-O-H. To remember, sine of angle D is opposite over hypotenuse. Opposite side over hypotenuse. You can do the other two. Go ahead and fill it in and come back when you're done. Ka, toa. And there we have it. Now we're going to apply it to finding side lengths. To find side lengths, we've got these three steps. First, label the sides from one acute angle. Remember when we say label the sides, we mean hypotenuse, opposite, and adjacent. Then write a trig equation using a side you have and a side you need. We'll see how to do that in the examples to come. Finally, we'll solve the equation, making sure that our calculator is in degree mode. That's very important. Let's take a look at the first example. Write two equations that could be used to solve for x in the same triangle. Now, it looks like I gave you two triangles, but really, I just want you to be able to label them differently. So in the first triangle, we're going to look from this acute angle and label the appropriate sides. First, we use our right angle as an arrow to point to the hypotenuse. This side right here across from the right angle is hypotenuse. So let's label that hypotenuse. Then from our acute angle, we look opposite from it, and that side opposite, we label opposite. Next to this acute angle, we label that adjacent. So there we've labeled our sides according to this acute angle of 78 degrees. Now, anytime we do trig, we want to write SO, CA, TOA. So we do that first, SOHCAHTOA. TOA. Now remember the other second step. After we labeled the sides, now we write a trig equation using a side you have and a side you need. So one we have and one we need. Where are those sides? 4, that's one that we have, and x is one we need. So I need to use adjacent and hypotenuse. The opposite, no. This has opposite and this has opposite. Adjacent and hypotenuse is cosine. So from this angle of 78 degrees, I can write cosine of 78 degrees equals adjacent comes before hypotenuse. So adjacent over hypotenuse. And there's my first equation. Now, the direction said write two equations that could be used to solve for x. So in this other picture, I would be doing the exact same thing if I use the 78 degrees. So instead of looking from this angle, I'm going to look from the other acute angle. Now I don't know how much that is, but I can find it. Remember the two acute angles in a right triangle add up to 90 degrees. So first I'm going to say 90 minus 78 to get that missing angle measure. That's 12, so this missing acute angle is 12 degrees. Now I'm going to look from this acute angle. I always start with the hypotenuse because it's always the same no matter what. Using the right angle as an arrow, I'm pointing to this side right here. So this is my hypotenuse. From the 12-degree acute angle, I look opposite, and that's this side. Then the last side, or the side that's touching the 12-degree angle, is adjacent. Now, again, I'm using trig, so again, I'm going to write SO, CA, TOA, and figure out what to use. So remember we said use a side that we know, that's the 4, and a side that we don't know, that's the x. That's O with H this time, not adjacent, not the A, here's an A, not the A. Opposite and adjacent, That's sine. So I'm going to write sine of 12 degrees equals opposite and opposite and hypotenuse. Opposite is 4 over hypotenuse, which is x. So the first thing we were supposed to do is done. Write two equations. Both of these equations can be used to solve for x in the same triangle. Notice nothing different was given. I just have two different ways that I could solve it. Now let's talk about how to solve it, and we'll round appropriately. So I rewrote this equation so that I could say that here is a fraction. Over here is not a fraction, and if I don't see a denominator, we know we can always make it a fraction where the denominator is 1. So now I have fraction equals fraction. I have a proportion. How do we usually solve proportions? We cross multiply. So we would multiply this times this and this times this. Now before I go and do that, I want to recall that when I cross multiply, I multiply those things together, and it doesn't matter where they are located to multiply them, meaning the x could be here and the cosine 78 degrees could be here. Because that makes it more useful to solve the equation, I'm going to use that property of interchanging those numbers so that it makes it easier to solve. So instead of cosine 78, I put the x up here, and instead of x down here, I put cosine of 78 degrees. Now please, every time you write that angle in here, you put the degrees. That'll help you remember to use degree mode. Now I don't really need the over 1 because x divided by 1 is the same as just x. My point here is when x is in the denominator, we're going to divide. So now we take our calculator and we type, well, wait a minute, let's go to mode and see if we're in degree mode. I am, so I'm good to go. Now I type it all at once, 4 divided by cosine 78, close the parentheses, enter. The direction says round to the nearest hundredth. Always pay attention to the direction. Hundredth means 2 decimal places. So I'm going to look at two numbers past the decimal point, 1, 2. The number after is big enough to round that 3 to a 4, so 19.24. So let's write that. X is approximately 19.24. And there's our second answer. So remember to look for how to round. Hundredth means 2 decimal places. Now be careful because it won't always say how many decimal places. It might use the word hundredths or tenths or thousandths. You have to know what that means. Let's try this one. Sine of 12 degrees equals 4 over x. Switch the places when x is in the denominator so that we are dividing by the trig ratio. Now we go to our calculator and type in 4 divided by sine of 12. 4, I'm going to have to scoot this over, divided by sine 12, close parentheses, enter. Notice we get the exact same thing because we were given the same problem, we just chose to look from a different angle. So again, I can write x is approximately 19.24. Make sense? Let's try a few more and you'll start to get used to it. Find the missing side length of each right triangle using trigonometry, round to the nearest tenth. What does tenth mean? 1 decimal place. So step 1, look at our acute angle and label the sides opposite, adjacent, hypotenuse. Always start with that right angle, look across from it because it's always the same. There's hypotenuse. From our acute angle, across is opposite. This side is opposite, and then next to it is the side adjacent. Now, we're using trig, so I'm going to write SOHCAHTOA. We have to pick a side that we have that's the 12, and a side that we need, that's the x. OA, that goes for tangent. So now I write tangent, the angle from which I'm looking, 68 degrees equals O before A. O is the x, A is the 12. Now notice that this time the x is on top. So we don't have to do any interchanging to get x by itself, but we do have to get rid of the divided by 12. So I'm just going to rewrite this so that I don't have to work with my original equation. I can show my step on the new equation. To get the 12 that's divided to go to the other side, we do the opposite. Multiply times 12 to both sides, and it's gone from this side. Now, x will be by itself, and it's 12 times the tangent of 68 degrees. Now I go to my calculator. 12 times tangent 68, close the parentheses, the nearest tenth, one number after the decimal point, and the 0 that's after keeps that as 7, 29.7. X is approximately 29.7. Good. So back to that note, notice it says when we solve the equation, we multiply when x is on top, we divide when x is on the bottom. If you have your highlighter with you, go ahead and highlight that because that's going to be really helpful to remember. Multiply x on top, divide for x on the bottom. Let's go back to that problem we're looking at. See the x's on the top and we multiplied. In the previous problem, see the x's on the bottom and we divided.